Good morning, Shivani.
Good morning, sir.
Shivani, are you also based out of Pune?
Yes, sir.
Okay. Hi, Hari. Good morning.
Good evening, sir. Good evening, everyone. Sorry, good morning.
Just wait for more minutes and then we'll get started. Okay, let's get started. So, today morning, you would have seen a brief discussion between Shivani and myself on something called as erasure coding. Okay. Now, before we move on to the next topics in data protection, we'll quickly understand a little bit about erasure coding, what it is, how is it different from, let's say, the RAID that we have learned yesterday, and why it came into existence. All this let us learn today. Okay, just a minute. Okay, just seeing which animation. Okay, I got one. Let me share my screen. Okay. Are you all able to see my screen?
Yes, sir.
Great. So first, a little history about erasure coding. See, what we have seen is we when we had hard disks, right? This RAID came into the picture, and it allowed us to protect the data from any kind of hardware failure, or this the same technology can be used to retrieve data even during case of software level corruption, okay, at the file system level. And we saw there are three different types of RAID, right? RAID with striping, RAID with mirroring, and there is RAID 10, which is a combination of both striping and mirroring. And we also saw that there is parity based RAID, and we understood that parity is nothing but an XOR calculation that happens at the binary level, and that XOR calculation allows us to create something called as a parity stripe. And even if one fragment or two fragments, depending on RAID 5 or RAID 6, are lost in the form of a disk failure, then using the surviving fragments, you should be able to recover or retrieve the data from the lost drives. Okay. Now, if RAID was already there, okay, what was the use to come and invent this kind of technology called as erasure coding? Okay. And what is its use? So basically, this erasure coding technology came into existence because of something called as high availability standards, which the customers are expecting uh, from the storage systems. Okay, the standards are and the expectations are increasing day by day. So this is called as five nines availability. Okay, 99.999% of the time data should be available. Okay, there is also six nines and seven nines availability. Okay, yes, you see, this is the expectation of the customer. Okay, that whenever I am writing data to a storage system, this is the amount of availability they want. So out of 10 million files per 100 years, you are allowed to lose one file only. Okay, so that is the amount of resiliency that the customers are expecting. So it is near zero. Okay, whatever they are writing to the storage system, it should always be available, and there should be no data loss, no data corruption, nothing at all. That's the expectation. Okay. Now, what was happening in RAID is RAID was a technology that was built, many years back, and it was primarily taken into consideration, or what all algorithms that went into building RAID, all those were built considering spinning hard disks. Okay, but when SSDs came into the picture, the algorithm was still used for SSDs, but it was getting inefficient. Okay, and using RAID, there were also some limitations. Some of you people have put in the WhatsApp group that what is the maximum number of disks that you can have in a single RAID group, right? In some it was 20, 28, 30, 34, some 70, but that's about it, right? You are not seeing any numbers bigger than that. But when we saw and started learning about the concepts of storage, we saw that a single storage system can have hundreds of drives. That means what? You will have to go and end up creating these small RAID groups all across the storage. And hence, just managing these RAID groups, okay, or small RAID arrays across a storage having, let's say, 500,000 drives, That itself becomes a challenge. Okay, keeping track of which RAID group has how many disks, what kind of disks, okay, whether it is full, whether it is empty, all these overheads. Okay, so people were constantly looking for a better solution which can stripe across hundreds of devices, okay, without degradation in performance, without degradation in availability and durability. Okay, so that is where erasure coding came in. Now, these availability is also not just measured in how much data loss can you take, but also how much downtime. If it is 5 nines availability, it says your system can be down only for like 5 times in an entire year. Okay, 5 times in an entire year, 5 minutes in an entire year. That means 365 multiplied by 24. That will be the number of total number of hours in a year. Then multiplied by 60, that will be the total number of minutes. In that total number of minutes, 0.0001% of the time only your system can go down. That is like 5 minutes in an entire year. And with SSDs, the expectation is even higher. Your downtime can be no more than 30 milliseconds per year. Crazy. Okay. That means even for a single second, your storage system cannot go down. Okay. That's the expectation. So now one learning task for today. On day one, all of you had prepared a sheet where you identified who are the top data center providers across the world and across India. Correct? I want you to revisit them and check what is the highest availability they are promising to their customers for the infrastructure that they are providing. Okay, and you will be surprised. Okay, so many of them are not even close to these numbers. Okay, so please do that research and see what is the availability that each data center provider is assuring their end customers when they are hosting their applications or their devices inside these data centers. Okay, now this we already understood. Mean time between failure. What is mean time between failure? Can anybody tell the answer? We had learned it yesterday. Anybody? It is the average time between setting up a particular disk and the time in which it is expected to last, or by when it will fail. Okay, that's the mean time between failure. And as I said yesterday, you cannot pinpoint the exact time when any device or any drive is going to fail. Yes, you can get some indications, but you cannot pinpoint the exact time. That's why you can only bring out an average. You cannot really specify a time. And that's called mean time between failure. That's why mean time, mean means average, right? Average time between failures. And recovery time. This is also very important. So we yesterday saw that there is also a time taken to rebuild the data. Just because RAID is there, or just because now we'll understand erasure coding is there, doesn't mean that when we replace a hard disk and put a new one into the storage system, or new disk instead of the failed disk into a server, doesn't mean that that lost data is going to be available to you just like that. Okay, no, it will take time. Okay, and that is called as mean time to recover or rebuild times. Okay, how much time it actually takes to rebuild the data that was inside a failed hard disk. Okay, now because of all these issues, newer technologies are coming into the picture. Now when we talk about a data center, these are the three components that we have seen form the data center. We have the storage or the host, We have the server or the host on the left hand side, then we have the network, and then we have the storage. The storage has controllers, and then we have the disks or the SSDs. Now, as we understood yesterday, each point in the data center, each component can actually fail. Okay. And we need to build technology, we need to build an architecture in such a way that even if there is a failure, there is no loss of data, number one, and whatever data is there on the storage, it should be accessible. Okay, it should be you should be able to read or write to it. Okay, and these RAID technologies are mostly taking care of the failure domain, which is on the extreme right, which is the hard disk only. And that is where we saw that redundancy mechanisms came in. The first redundancy mechanism that we learned yesterday was RAID. And in RAID, we had mirroring, which is nothing but, RAID 0, sorry, RAID 1. And then we had striping plus mirroring. Okay. Yes, the costs are high and the performance is lower. And then we saw parity also. We saw that parity is nothing but XOR of binary. Okay. And when we have stripes of data, you can do an XOR of D1 of the data stripes and you will be able to get a parity. And the parity is actually stored diagonally across multiple drives in the RAID group. Okay, like that. Then we have dual parity also, RAID 6. Even if there are two disks that get failed, using the surviving data disks and the parity disks, you would be able to reconstruct the data. And we saw how to do that using the XOR calculator, right? So the same thing happens inside the memory. Okay, but we all saw that this parity, calculation takes time, right? And this is where erasure coding is born. So what erasure coding does is, without having the overheads of performance, okay, still parity calculation you can do, okay, but at a much lesser overhead. And that's the concept of erasure coding. And when we do erasure coding, we generally speak in numbers of n plus something. And you would have seen Shivani had responded to my message saying that yes, Pure Storage uses n plus 2 erasure coding. Now, what does that n plus 2 mean? Okay, as you can see in the screen right now, okay, n is the number of data fragments. Okay, or at a high level, you can also say n is the number of disk drives. Okay, data drives. And what is p? P are the number of parity fragments. Okay, P is the number of parity fragments. All right. And when we say n plus 2 erasure coding, whatever be n, that means it may be 3, it may be 4, it may be 6, it may be 12, you will still have only two parity fragments. That is why it is called n plus 2 erasure coding. Okay. And because you have only two parity fragments, the maximum number of disk failures that you can sustain and still recover the data back is 2. Okay. And hence this is also called n plus 2 redundancy. Okay. All mean the same thing ultimately. How many failures can you withstand simultaneously? Okay. So when we are doing n plus 2 erasure coding, that plus 2 stands for actually how many parity fragments are we creating in order to protect the data across n data fragments. And that n number can be anything: 4, 5, 6, 8, 12, 20, 30, 100, doesn't matter. Okay. And moving forward, this is the best part of erasure coding. Okay. Whenever you want to increase your durability or redundancy of the system without having to hard bind the disks in specific RAID groups. Yesterday we learned one important thing, right? That whenever we are applying RAID to a hard disk, that hard disk can participate in that RAID only. The same hard disk cannot participate in multiple RAIDs, correct? Which means if I have to change the RAID layout of a given set of hard disks, I cannot do it on the fly. I have to erase all the data that is there on the RAID or back up to somewhere else, completely delete that RAID configuration and create and apply a new RAID onto the disk. And after that only you can write new data. So on the fly, while the disk is spinning, while the power is on, while data is already residing on the disk, I cannot change the RAID configuration on the fly. Okay, it's not possible. It's not possible in servers. It's not possible in storage systems. Okay, anywhere where RAID is applied, it is not possible to change the RAID scheme or RAID type on the fly. Whereas in erasure coding, you can do that because you are not binding the disk or the drive to a particular RAID type. All this is happening at the software level in the memory. Okay, there is no linkage, okay, to the physical disk drive when we are doing erasure coding. Okay, if all these calculations of striping the data in the memory into smaller chunks, creating the n number of data fragments, and then whatever is your erasure coding scheme, n plus 2 or n plus 4 or n plus 6 or n plus 8 or whatever, okay, you're doing all of this in the memory. Okay, and after it is done in the memory of the storage system, you are just writing that parallelly into multiple hard disk or SSDs, okay, in the storage system. And hence, depending upon your need, especially when the storage systems are getting larger and larger, okay, in terms of number of hard disks that can be stored, you can change the erasure coding scheme on the fly. Okay, you don't need to wipe out existing data, you don't need to do any backup and recovery. Okay, all that is not required. Okay, on the fly, while the system is up, while the hard disk is running, while the SSD is running, while it has got data in it, okay, you can upgrade the erasure coding schema on that particular hard disk. And this is the biggest advantage of erasure coding versus RAID. And that is the reason why today all the latest storage systems that are coming in the market, especially the ones which do only SSDs, like in Pure Storage, Shivani, okay, there is no spinning hard disk at all. They have not even considered spinning hard disk. Okay, each and every hard disk, each and every disk inside Pure Storage is only an SSD. Okay, various types are there in SSDs also, but only SSDs, and hence Pure Storage does not use RAID at all because there is no spinning hard disk. Okay, because RAID was meant for spinning hard disk, and hence they use only erasure coding. Okay, similarly, some larger storage systems, the ISRO example that I was talking about to you earlier, those kind of storage systems called Isilon, they also use erasure coding. They don't use RAID. Okay, so as you will see in practical scenarios that as and when we are getting into larger systems, as and when the demand of the customer is increasing in terms of availability, you saw that even 5 nines availability is something that is not acceptable today. People are expecting 6 nines, 7 nines, 8 nines, 9 nines availability. Okay, which means absolutely no data loss is acceptable. That is where erasure coding comes into the picture. All right. So these are some of the benefits of erasure coding. You can, stripe your data across multiple at no additional so much cost. Okay. Same durability, but at half the cost. Okay. And even if you increase your erasure coding schema for uh, better this one, you are not going to increase your cost. Okay. Yes, this is also true. Erasure coding is mostly used on cold data. Why not on hot data? Yes. When you're doing mirroring, you're just copying of data, so not much of compute requirements. Whereas in erasure coding, the compute requirements are very high, and you know that's why it makes it a little slower. Okay. So because there is this in between one more step called as encoding, and whenever you're reading the data, there will be one more step called decoding. Okay. And whenever new disks are there, this kind of a reconstruction happens. So that is refolding. So of course it is more complex compared to simple replication. Yes. So data processing unit is there, but we'll not talk about this data DPU right now. I don't want to confuse you with a lot of things, okay, at this point in time. So hope you have understood what is erasure coding and how it is different from RAID. Any questions about erasure coding? The most common algorithm that is used for erasure coding is this, okay? Reed-Solomon algorithm, okay? Reed-Solomon algorithm. That's the algorithm that is mostly used for erasure coding. Okay. So one more task for today, apart from understanding the availability of data centers, just do a little bit of reading on what is Reed-Solomon algorithm. Okay. Any questions? Okay. If there are no questions, we'll move forward. Right. Yesterday we were here, right? We understood what is RPO. We understood what is RTO. We understood that RPO is point in time in the past, RTO is point in time in the future with respect to if you take T0 as the time when a disaster would happen. Okay. So ultimately, what is happening here is when we are recovering the data at this point in time, the data will look as if it was at this point in time. Okay. So the business should be ready to withstand this much amount of data loss, and uh, they should be able to bear the downtime because of a disaster for this much amount of time. Okay. So those things they need to consider and keep their end users informed. Okay. Now one more, uh, one of my favorite topics is snapshots. And we'll understand what a snapshot is, why we need it, okay, what exactly happens when we are doing a snapshot, and how is it used effectively in a storage system to protect data. Okay, that's what we are going to see today, and it's very interesting topic, so kindly bear with me and please be attentive. All right, so let this slide build up, and I will tell you more about this, and I'll give you a practical example also. Okay, let me stop sharing for a minute. Okay, now, uh, any of you have attended marriages? I'm sure you have, right? Just a raise of hands. Yes, yes, yes. Okay. When we, after the marriage is complete, okay, you get two types of outputs from the photographer, right? One is a set of photos and one is a set of videos, right? Okay. These are two things we get. Now, what happens is when we are looking at the photo, okay, our mind goes back to that point in time when that photo was taken, isn't it? And that photo is representing a point in time in the past, and it shows you how you, the bride, the bridegroom, and their relatives were looking at that point in time in the past. What happened prior to that, what happened after to that, you have no clue just by looking at a single photo. All of you agree, right? So when you're looking at a photograph, you are looking at only a one particular point in time in the past. Okay, you you don't know what happened before that photo was taken, and the photo cannot tell you what happened after that photo was taken. Exactly at that point in time when the shutter of the camera was clicked, that photo was taken, only that particular point in time is reflected in that photograph, right? But when you look at a video, it's a completely different experience, isn't it? What is that experience? It is telling you that entire story from starting to beginning. Nowadays, so even there are pre-wedding shoots. Okay, crazy, right? Very funny as well. But it is giving you the complete story, right? So you know where it all started, okay, how the marriage date was fixed, then the marriage, then the entire marriage function, then what happens next, okay. And let me tell you by experience, there is never happily married ever after, okay. So you can remove the word happily. But anyways, jokes apart, the video is going to give you the complete idea of how it all started and where is the current location when the video is ending, okay. And this is exactly the difference between these technologies that we are going to learn now, okay. So sharing my screen again. What is a snapshot? Okay, we understood that whenever we are storing data in hard disks, right, and we saw it in your laptops also, that there is a file system on top of it, right? In our laptops, it's NTFS. In one person's case, it was REFS. Then there are different kinds of file systems. In Unix, it's EXT, like in Mac. Okay, so there are different kinds of file systems. What are these file systems? They are understanding or keeping track of where which data is stored on the tracks and sectors of the hard disk, so that when you want to read that data, it is able to serve you, and when you want to write new data, it knows where are the gaps in the tracks and sectors and will allow you to write new data onto that. Or if you're modifying any existing data, it knows where to read from and where to overwrite. Okay, but during all this process, definitely there are instances where software level corruption can happen at the file system level, okay. And you see one use case here. User may accidentally delete a file unintentionally, okay. They may delete a file, okay. Some of your critical marriage photos or marriage videos may get deleted, okay. Then what? Then the first thing that you can do is try to recover from snapshots. And what exactly is a snapshot? A snapshot is like a photograph of the data, basically of the file system, as if it were at a previous point in time in the past. Okay, it's as if there is a photographer, constantly, ready to take photographs inside the storage system. And whenever you say snapshot, click, it will take a snapshot and keep it, and will note down the exact time, hours, minutes, seconds, milliseconds. Okay, and it will keep a journal or a metadata of that, saying that okay, when you are looking at this snapshot, you are actually referring to data which was at that particular point in time in the past. Okay, even if data changes after you take a snapshot, but when you look from the snapshot, you will still see that old data only. That means whenever you're taking snapshots, in order to protect your data, it is keeping a few fragments of your data of the past also. Are you able to understand? To protect that point in time view of the data, to give you access to that old data. That old data should be present in the system, right? And hence, even if you're overwriting any data on an existing file, the previous view will still be there. Okay, which means those old data fragments will still be there in the system. Okay, and using those old data fragments, you can do things like recover a deleted file or a folder, or recover from a some kind of a corruption that may have happened. Okay, or any other event that may have resulted in accidental data loss. Is this clear? What is a snapshot? There are various technologies available. We'll get into those details later. Any questions on what is a snapshot? And these previous or old data fragments to which the snapshot is pointing to, they will be stored in a separate area. So you need a little bit additional space in order to implement snapshot technology in any storage. Typically that space is 15 to 20%, but it will depend upon the rate of change of data. So that we will see later. But this kind of technologies are available in today's storage and server systems. Okay. All right. Then we get into, now we saw how storage system takes photographs. These photographs are nothing but snapshots. Okay, it needs some additional space, but only 15 to 20%, and it allows you to recover from software level failures. Okay, like accidentally deleting a data, some kind of a corruption happening. Okay, quickly it will allow you to recover. Okay, without taking much time and without taking much additional space. Right, but when we go to the next, uh, you know, technology, this technology is like taking a video and keeping that video somewhere else, not on that same storage system, sometimes in tapes also, say in a different storage medium altogether. Okay, so as you can see the diagram here, backup is a completely additional copy like a video. Okay, every data block, every data chunk that has been written to your primary storage node, everything will get backed up. Okay, and these backups will happen at specific frequencies. Like in our phone, we backup every day to Google Drive or iCloud, something, right? That means what? Physically, a separate copy of data is being maintained somewhere else. Okay, in this case, in Apple's data center or in Google's data center. Okay, apart from your phone. Similarly, when we are talking about servers and storage systems which are storing critical data, you can create a completely separate copy of the data elsewhere, okay, using a technology called backup. So backup software is a different software altogether. Okay, this backup software does not reside inside the storage. Okay, it's a completely different software. So you need a separate server to run a backup software. Okay, and that is what you see here, right on the top. This server is called as a backup server, nothing but similar to this server only. Okay, where your application or your production data or your workload is running, but the purpose is different. Okay, you are not going to run the production workload, you are going to run a different kind of a software, and that different kind of a software is called as a backup software. Okay, and hence once you install a backup software on this kind of a server in the data center, people start referring to it as a backup server. Okay, now these backup servers are designed to simultaneously take backups from multiple sources in the data center simultaneously. Okay, so if there are 5 storage systems in a data center and let's say 200 to 300 servers, you don't need that many backup servers. A single backup server is actually enough. Okay, which means a given backup server can simultaneously take backups from multiple sources in the data center and consolidatedly write it to a separate kind of a storage system. And that storage system can have disk media or it can have tape media also. Okay, and typically if you are using disk, you will use 7.2K RPM drives. Okay, SATA drives you will use. Okay, 7.2K RPM, and high density drives you will use, like bigger capacity drives you will use. Okay, so that the cost is lesser. And then you can use tapes. Okay, tapes are measured in generations, like LTO is followed by a number is called the generation name. LTO1, LTO2, LTO3, so on and so forth. So and we also understood that tape medium needs tape drives. Okay, so we will need tape drives to read and write data into the tape. So what is the advantage of having backups? Even if the complete server is down, even if the complete storage is down, it got encrypted by malware, or you know somebody accidentally did delete star dot star, okay, everything. Okay, or an employee of the company, he was pissed off by what his manager said. He wanted to delete the complete data before he left his job. Okay, so such kind of people are also there. All right, so when such a thing happens, how do you recover? You use these backup software to recover from the data. Okay, now what exactly is a backup software, what kind of backup softwares are there, all that we will learn in our intermediate and advanced courses, right? Any questions on backup? Any questions on what is backup?
So what should be data corruption, sir?
In where? Inside backup or inside storage?
Uh, in backup, sir.
Good question. Good question. So yes, since backup is also using similar kind of storage mechanism, there is a possibility of data corruption in backup also. So what backup software does in order to ensure the guarantee that whatever data you are backing up is 100% recoverable is they do some kind of error checking. Okay, they do error checking mechanism before permanently writing the data onto tape or onto disk as the backup target. Okay, typically this error checking is done by using a hashing algorithm called MD5. Okay, And what it does is, while it is reading the data from the source, maybe your web server, maybe your virtual machine, maybe your files or folders, maybe your NAS system, okay, maybe your web server, whatever it is, doesn't matter, okay. And we know that once you're reading the data, that data is striped or sliced into chunks, right? So for each chunk, it will run the MD5 hashing algorithm, and a hash key will be generated. Okay, 128-bit hash key or a 256-bit hash key will be generated. Okay, then the backup software will do its own, processing of that chunk of data, and after it has written the data to the backup target, okay, uh, it will read that data once again into the memory and recalculate the MD5 hash checksum for it, okay, and then it will compare, while I was reading, what was the hash, and after I have written to the storage item what is the hash, is this matching, okay, and this it will do for every chunk of data, okay. And that is why many backup softwares can give a data recovery guarantee, okay. Not every software can give, but many, there are softwares available that can give this guarantee because of this error checking mechanism that they do before they write to the backup target, okay. And we understood that within the storage, anyways there are other mechanisms. There are mechanisms like RAID, there are mechanisms like erasure coding, there are mechanisms like snapshots which can protect the data inside the storage, okay. But to eliminate any software corruption that can happen during the read and write process from a backup perspective, the before reading it will do an MD5 hash. After writing, it will do an MD5 hash. It will check both of them in the memory. If it is matching, that means whatever you read, you are writing it exactly the same way, and hence that's a good write. Okay, so you don't have to look at it again. Like that, it will do for all the data chunks that are coming, and it will do it on the fly while the data is being read, and then while it is getting written, it will do on the fly. Okay, understood?
Yes, sir.
Great. Any more questions about what is backup or what is snapshot? No? Okay. Now we go to the next stage. Okay. Now, before I understand, before we understand what is replication, one question about backup. Do you think this process of backup will happen instantaneously, or is it going to take time?
It's going to take some time.
It will
Yes.
take some time.
Yes, correct. And it will take good amount of time. Okay. Because when you're reading from the storage or your primary source of data, already some servers users are accessing that data, na? Okay, so already read and write operations are happening on that. On top of it, you are bringing this backup software and asking that also to do reading of data from the source. And obviously you will give lower priority to the backup because primary priority or the first priority is serving the production data, okay. And hence always the backup software is going to take additional time to read the data slowly in a sequential manner, okay. And then whatever it is reading, it has to write, okay. So that writing is also going to take time, right? So backups do take time, okay. And because of that, let us say I initiated a backup for, let's say, 10 terabyte of data today morning at 9 a.m, okay. And let us assume that for 10 terabyte it takes 2 hours to complete, okay, the backup, all right, for 10 terabytes. Then what is my RPO, recovery point objective? What is my RPO, recovery point objective? How far behind can I go? 2 hours? Because Until and unless the backup is complete, I cannot recover it from it, na? So when I'm sitting at 12 o'clock, and let us say at 12 o'clock a disaster happens, okay, and I want to recover the data. Recovery is going to take time. Let us say it takes 3 hours to recover the 10 terabyte data. So at 3 o'clock, when I'm recovering the data completely, how will it look like? Will it look as if the data was at 12 or will it look as if the data was at 10?
Because we have the data like backup uh, at 10, so it will look like 10.
Exactly, correct. Because we started our backup at 10, it will take a snapshot at that time. It will read from the snapshot. So always this backup copy which we have taken, it will, whenever we are recovering from it, it will show the recovered data as if it were at 10 o'clock, not at 12 o'clock. Okay, so your RPO is 2 hours. Okay, and what was the RPO? RTO, since it took 3 hours for you to recover this complete data and bring the systems online, your RTO is 3 hours. Okay, so if a disaster happens at 12, at 3 p.m. in the afternoon, you can recover and see the data as if it were at 10 a.m. in the morning. This is how it works. Okay, but in today's world, do customers have so much of patience? First, to wait so long, number one, and second, to have so much amount of data loss. Okay, just imagine, let's say you have your account, financial account in HDFC or ICICI. Okay, and maybe some systems have failed, and HDFC comes and says, boys and girls, we are very sorry. Whatever transactions you did between 10 to 3 o'clock, they are unrecoverable. And if you have put in some money digitally, sorry, we cannot recover that data. That is as good as lost. Will you accept? You won't accept, right? You will hit them hard on their face. Okay. So you will not accept. And forget you, RBI will not accept, SEBI will not accept, no government will accept, right? So, what can the IT guys in the bank do to give you that assurance that no matter what, okay, we are always keeping your data protected till the last byte, okay? And that technology is called replication, okay? And this technology is widely used in data centers today to create online to the point replicas of your data in a separate storage system. All right. But there are certain assumptions and considerations for replication. Okay. Primarily, replication happens only between similar storage types. Okay. Which means if I have NetApp storage system as my source, NetApp can only do storage level replication to another NetApp box only, not to HP, not to Huawei, not to Pure, so on and so forth. It doesn't happen. Okay, so replication is a proprietary technology. That means it can happen only between various models of the same manufacturer. Okay, it cannot happen across manufacturers. There are technologies available to do that also, but we'll talk about it later. Okay, forget it. But when you're talking about storage to storage replication, okay, whatever write happens on storage 1, the same write will happen on storage 2, and hence you're protecting all your data. That kind of replication happens only between storages of the same manufacturer, okay, not across manufacturers. But when we learned about backup, in backup, okay, other storage systems are possible. So this backup target, okay, can be from any other manufacturer, doesn't matter. So your source can be NetApp, whereas your backup target can be EMC or Dell or Huawei, no problem. Okay, because there is no direct dependency between reading data from the storage system and writing to a target, because storage software is taking care of it. Okay, but in case of replication, that is not happening. Okay, because the storage is taking care of replicating all the data. Only it can happen from the same manufacturer to same manufacturer. Okay, and here is where we can have zero RPO, zero RTO solutions by using replication technology. That means not even a single byte of data needs to be lost, and at the same time, instantaneously on the other storage system, you can start running your workloads. Okay, almost instantaneously. Okay, so very close to zero RPO and zero RTO. Okay, can be achieved by using replication technologies. All right, but it is easier said than done. There are a lot of considerations at the network level and at the server level in order to achieve this. Okay, just imagine, no? This guy, this server, all this while was writing data to this storage system, and all the SCSI protocols are mapped accordingly. Suddenly you ask it to start reading and writing from the other storage system. I mean, it's not magic, right? So something has to be done, okay, in order to make sure that whenever this is not reachable, immediately from the next millisecond onwards, these servers should start writing to the start reading and writing from the other storage system. Now, this storage system has got its other identity. It has its own bus number, SCSI ID, and all those things. So, how is it possible? So, there are certain things that we do at the server level, okay, and at the network level to make sure this happens. Okay, so what are those? We will learn later. Okay, I'm not going into the details of it right now, but those technologies are available and we will be using them to make sure that whenever we are doing replication, we also implement these additional few things at the server level, so that whenever this switchover happens, it's called failover or switchover between the failed storage system to the surviving storage system or to the replica, the data will start reading and writing from the other storage system. Okay. Any questions on what is replication? So both backup and replication are like videos, but have different purposes, have their own advantages and disadvantages. Okay. Any questions?
Sir, I have one doubt.
Yes.
So, the standby server which we are talking, can we do the replication on intervals?
Yes, we can do. So replication has different modes. Okay. There is synchronous replication and there is asynchronous replication also. Okay. Synchronous replication means as and when data is coming into storage system 1, exactly at the same time data is going to storage system 2 also. Okay. There is very little delay. I mean, the delay could be measured in milliseconds or nanoseconds. Okay. So almost instantaneously, that every byte of data coming into storage system 1 is going into storage system 2. This is called as synchronous replication, completely in sync with each other. Okay. But there are cases where asynchronous replication is also needed. Okay. Asynchronous replication means what? You are going to do this replication task in intervals of 1 hour or intervals of 2 hours or intervals of 4 hours. Okay. Now, why this is used and how it is applied, let me show you. 1 second. Just give me a minute. Mm, just give me a minute. Trying to get the ideal diagram and the simplest one for you to understand. Hmm. Okay, let me take this diagram to explain to you. Okay? All right. So, whenever we are setting up disaster recovery, like for a bank or a telecom company or for a pharma company, we are going to suggest them a multi-site disaster recovery strategy. Okay. What do we mean by a multi-site disaster recovery strategy? We are going to build an architecture where the same data is not going to be stored only in one data center. Okay, it's going to be stored in multiple data centers simultaneously. Okay, and how do we choose? Okay, where the data centers should be placed? Okay, so first thing that you need to understand is this seismic zones. Okay, what is a seismic zone? What happened to this? Mm, yeah. See, we all know that various places on the planet, okay, are susceptible to earthquakes, right? So all the geologists across the globe, they have divided the entire world into various seismic zones, okay, where seismic zone means what is the probability of having an earthquake in that region. Okay, what is the probability of having an earthquake in that region? Okay, and you will see they have categorized these zones into uh, multiple uh, multiple types. Okay, and they have given some rating: zone 2, zone 3, zone 4, zone 5. Zone 2 being least susceptible, or the probability of having an earthquake is the least, and zone 5 is the highest. So in India, you can see that Himalayan region, okay, uh, right from Jammu Kashmir all the way till Assam and the neighboring states, okay, All these are very highly active seismic zones. That means the probability of having an earthquake here is very, very high. Similarly, in the tip of Gujarat, okay, near the Rann of Kutch, okay, uh, the the seismic activity is really, really high. Okay, then comes zone 4. Okay, zone 4 is where very close to where Renu and Shivani stay, Mumbai. Okay, this is seismic zone 4. Okay, the probability is pretty high. Then we have zone 3, moderate seismic zones. Okay, you will see that just moving away from a high seismic zone, if you come towards the mainland, the probability of earthquakes keep dropping. Okay, and these are the areas that you see in Rajasthan. Okay, then in Maharashtra, Madhya Pradesh. Okay, these areas, some areas of Andhra. Okay, some areas of Kerala, then UP. These all areas. Okay, these are areas of zone 3. And in India, where is the least possibility of having earthquakes? It is in zone 2. Okay, zone 2. And guess what? Where is Bangalore? Bangalore is right here. Okay, Bangalore is here in zone 2. Okay, Mumbai is somewhere here in zone 4. Hyderabad is somewhere here in between zone 2 and zone 3. Okay, and this is the reason why many data centers come up and are still coming up in Bangalore and Hyderabad. Why do you think Microsoft, Amazon, Google are setting up large data centers, okay, in Hyderabad and in Bangalore? The primary reason is this, okay, because both of them are in zone 2 from a seismic zone perspective. That means the probability of an earthquake happening here is the least. Okay, now what has that to do with replication? Now, when I have to choose my next data center where I'm going to keep a copy of the replicated data, okay, how am I going to make that choice, or what are the suggestions that we can give to customer? Okay, because customer may or may not have an office, customer may or may not have a data center in a city in another seismic zone. Okay, it may not be the case. So that is where we will identify who are the data center providers, what you have learned in class 1. Okay, who are operating in that zone. Okay, and try to choose one of them based on cost, based on features, based on availability, and all of that. All right, but even before that, we will set up something called as a near DR site first. Okay, so let me just talk about this. Okay, DR sites. Okay, so first is number one will be near DR. Okay, near DR means less than 500 meters. Okay, less than 500 meters. That means maybe just another building in the same campus. Okay, that's called a near DR site. Okay, and then you have a metro DR site. Metro DR site means same city. Okay, but in different location. Okay, metro DR. Same city but in different location. Okay, maybe you can just go in 2 to 3 hours time frame. Okay, so the distance, from a distance wise, it will be like anywhere in the range of 100 to 150 kilometers, right? And then we have something called as far DR site. Okay, far DR site is anything greater than 150 kilometers of distance. Okay, anything greater than 150 kilometers of distance, ideally in a different city or different country or different continent. Okay. Ideally in a different city or a different country or a different continent. Okay. Now, one thing you'll have to understand is for every one production site, okay, for every one production site, you can have only one near DR site, okay, but you can have many metro DR and far DR sites. Okay, for every one production site, you can have only one near DR site. Okay, but you can have any number of metro DR and far DR sites. Okay, and here is where you will have to understand this, that when replication is done to near DR site, it will be synchronous in nature. Okay, synchronous in nature, and hence only near DR site can be 0 RPO and 0 RTO. Okay, you cannot achieve 0 RPO or 0 RTO with a metro DR or far DR site. Okay, because you cannot do synchronous replication, okay, to it because of the distance, just because of the distance. Okay, when you are transferring data to 100 kilometers, you cannot expect the acknowledgement back over the network in milliseconds. It will not happen. Okay, and especially when the data size is large, it is going to take time, and because of that there is going to be a delay, and because of the delay you can never do a synchronous replication. Okay, because it's going to impact your production, and hence only in the near DR site you can have 0 RPO and 0 RTO. Okay, and they, because it uses synchronous replication, and hence when you're doing metro DR or far DR, okay, only then in these scenarios you are doing asynchronous replication. Asynchronous replication. That means you are deciding the interval, okay, between one replication job or copy to another replication job or copy. Okay, if it is the metro DR, it will be the frequency of replication is going to be higher. That means you can do every half an hour, every 1 hour, like that. Okay, but when the distance is greater than that, when it's in a far DR, maybe a site in another continent, okay, obviously you cannot do every hour, right? So you will do every 3 hours or every 4 hours, okay, or maybe every 24 hours, something like that. Okay, so all of that can be possible, all of that is definitely done, okay, across the globe. As I told you, BSNL keeps at least 4 copies of data in various cities across India. Okay, these cities are Chandigarh, Delhi, Kolkata, Hyderabad, Mumbai, and Bangalore. Okay, these are the 6 cities. Okay, where we can do this. Okay, where BSNL does this. Similarly, some banks keep at 7 different copies of data, one near DR site and multiple far DR sites. Out of that 7 copies, one is in near DR, 2 or 3 maybe in metro DR sites, and the remaining 2 or 3 copies will be in far DR sites, some in different continents also. Okay, so that's how replication is set up, and that is what this diagram is typically telling. So if this is the headquarters, which is the production site, The near DR will be in the same campus, okay, just within a few hundred meters, okay, and you can have communication between them. And you can have only one near DR center, okay, near DR site. But when we are doing far DR, you can have multiple far DR sites or metro DR sites. Some may be in the same city, some may be in the another country, another city, another continent altogether. Okay, is this understood now? Clear?
Yes.
Okay. So now I took the example of seismic zone, but there are other things also. Okay, like they take into consideration amount of rainfall. They take into consideration amount of this one. What is that? Proximity to sea. Okay, because of now tsunamis are also a threat. Okay, so they take into consideration that aspect as well. All right.
And also
Uh,
geopolitical aspect.
Yes, geopolitical aspects also. Yes, very true. Okay, because in some politically unstable countries, you do not want to put your data center there, right? It doesn't make sense because at any point of time they can do something stupid, okay, which will lead to loss of power or loss of internet. Okay, all these things. So they will not do that. All right. Uh, you have to, as an architect, take into consideration everything that can fail, okay, including power, and take into consideration and then deploy mechanisms that will help you to recover from such situations. Okay. Okay, so we learned a lot of new things today. Okay, yesterday we learned RAID. Today we re-emphasized what RAID was. Then we learned a new technology called erasure coding, and we understood where it is used, why it is used, okay, how is it beneficial versus RAID, and what kind of storage systems use erasure coding. We learned that. Then we got into further kind of technologies to help you from recovering data. Okay, we learned about snapshots, okay, which is just like a picture taken of the data, reflects only a particular point in time in the past, helps you to quickly recover from deleted files or small amounts of software corruption and so on and so forth. But if the failure domain is higher than just deletion of few files or little amount of software corruption, you have to rely on other technologies to recover your data. What are those other technologies? One, you have backup, and second, you have replication. What is backup? Backup is exact copy of data from one workload to another place you are keeping. While doing the backup software does error checking in order to guarantee that whatever you have backed up is recoverable. Backup target can be disk, either HDD or SSD, and it can be tapes also. Generally in disks, 7.2K RPM SATA drives, high density drives are used as the backup storage medium. Okay, and there are various kinds of backup software available today. Okay, then comes the ultimate data protection mechanism. It's called replication. Replication is every byte of data as and when it is coming into the production storage system is getting replicated either to a single site or multiple sites. And there we also learned that how sites are chosen and what kind of various sites are available. So we have seen that we have a near DR site. Near DR site allows us to do synchronous replication, and that is where we can achieve near zero RPO and zero RTO. That means instantaneous replication and instantaneous recovery in the time of a failure. Okay, and going beyond that, then we have Metro DR. Metro DR is 100 to 200 kilometers of range, maybe within the same city or just next city. Okay, and trying to have a replicated copy there. And then you have far DR, another city, another seismic zone, another continent altogether, doesn't matter. And when we are doing near DR, only there we are using synchronous replication. Whenever we are doing Metro DR or far DR, we are talking about asynchronous replication. In asynchronous replication, you can specify the frequency of replication, okay, depending upon the distance, depending upon what kind of connectivity you have between the two sites and how much amount of data you have in your production site. You can set the frequency for asynchronous replication, separate frequency for metro DR, separate frequency for far DR. Okay, for any production site you can have only one near DR site, but you can have many metro DR sites and many far DR sites. Okay, any questions on these concepts? Okay, they look very simple when we are talking theory. Okay, when we want to implement this, that's where the skill comes. Okay, so as and when you work more on these technologies, you will appreciate, okay, the R&D effort that goes into developing these technologies. Okay, definitely it is done through software only. Okay, but this software is not to build other softwares. Okay, this is purely to protect data. Their only job in life is to protect data. Okay, and companies spend billions and billions of dollars to keep their data protected. Okay, and that is the reason why, boys and girls, I'm telling you that if you learn this technology, you will definitely get jobs, and the better you become in this technology, your salary bracket is going to only increase. Okay, people will come to you to take your advice, but it will happen over a period of time. Okay, not at once. Okay, I think we did a big mistake today. We didn't record this session. Okay, anyways, I'm also a human being. I do mistakes. I will try to just upload some content, basically that video what I have been showing you. Okay, and that I will put it up so that you can refer to it and you can go through it. Okay, sorry about this, but any questions and doubts you have, you please feel free to reach out to me. All right. Okay, thank you, boys and girls, for your time today. We'll meet again on Monday, and from Monday to a few days in the coming week, we will learn about cyber security and data security, and a little bit we will touch upon virtualization as a concept. Okay, and that will be the end of our basic training. Okay, where we would have touched upon most of the concepts in what goes on in a data center, but at a conceptual level. Okay, not at a practical level. All right, and that practical level training is what we will start in our intermediate class. Okay, thank you so much, boys and girls. Have a nice day. We'll see you again on Monday. Okay, yes. Please remind me to record. That will be really good. Thank you, Anand. Thank you. Okay, take care. Bye bye.